Tonight I want to review the different types of tracking found in SkyTrack. This video will be particularly helpful if you're just starting off in SkyTrack. We're going to talk about satellite tracking, and then we're going to talk about tracking astronomical objects. So with satellite tracking, there's two main types of tracking. There's continuous tracking, where the mount is continually moving, tracking across the sky at the same rate that the satellite is moving. And there's also leapfrog tracking, which can be used if your mount isn't able to do continuous tracking. And what it does then is it leaps ahead of the satellite along the path of the satellite, stops, waits for the satellite to come through the field of view, then leaps ahead again, and the process continues. So let's start with leapfrog tracking. So I'm going to unclick continuous tracking. I'm going to connect to my mount. You have to decide whether you're doing continuous or leapfrog before you connect to your mount. If I want to switch, I have to disconnect my mount again. So let's take a look at an object here. That looks like a good one. So we're going to start tracking that. And I'm going to switch over here. We're going to use Sharp Cap to capture video. Give it a little more exposure time. Okay, so we're in the middle of leapfrog tracking. So we should see the satellite pass through our field of view. There it goes. Then we're going to jump ahead of it again, stop, wait for it to come through the field of view. And there it goes. So that process continues. Now, it looks like a bit of a streak because I've got a really low frame rate here on my camera. If I decrease the exposure time, I've got a faster frame rate. There, it doesn't look quite as streaked. But through an eyepiece, it'll look quite nice. So that's leapfrog tracking. And there it goes. So we'll stop that. So you can change your parameters. You can say how many seconds ahead that you want to move the mount ahead, and then once the satellite arrives in the center of your field of view, how many seconds you want to wait till you do the next leap again. So those are good parameters to start off with. Now let's take a look at continuous tracking. So I'm going to disconnect. Now click continuous tracking. Not all mounts can do continuous tracking, and if you click on the help here, there's a bit of a discussion here about that. And also, once you connect via an ASCOM, if you go to the other tab, and you can take a look at the ASCOM capabilities, and it's this one here we want to look at. So if the mount can do variable rate slewing, so it says yes there, that's required for continuous tracking. So if your mount says no, then you'll only be able to do that leapfrog style of tracking. That's for ASCOM. For legacy, all the legacy interfaces can do continuous tracking, with maybe the exception of the LX2 compatible. Depending on what mount that is, it may not be able to do continuous tracking. But all the rest of these do continuous, and actually only continuous. This option will be checked and grayed out. If with one of these mounts you want to do leapfrog, then you can choose your ASCOM driver and do that. Generally, the legacy interfaces work better than the ASCOM interfaces, and that's discussed in that help here, why that is. So we're going to do continuous. So let's connect to our mount. And it's starting to get darker, so hopefully we'll get some good tracking yet. I'm going to pop that out because we might need that. So with continuous tracking, the timing is a little more critical than it is with Leapfrog. I can't see anything. I've got to increase our exposure here. So here we're chasing after it. Just going to zero that. And there's our satellite there. So our satellite now is relatively still in our field of view, and all these streaks going by are stars. And this is where I mentioned timing is a little more critical. So as I click these left and right, that adjusts the timing along the path. And there we have it pretty well centered. So that's continuous tracking. Close that camera. So the last type of tracking that I want to talk about with satellites is actually no tracking at all. And I'm going to select a geostationary satellite. So a geostationary satellite is fairly far out there. So you see its altitude is much, much higher than the ones we were just looking at. The ones we were just looking at were around 450 to 500 kilometers in altitude. A geostationary is out in that zone because a geostationary satellite stays in one position in the sky relative to the viewer on Earth. And we'll see what SkyTrack does when we try to track a geostationary. So I'm going to have to do, it's doing a meridian flip here to come on this side of the hemisphere. And there we're on target now. And so what SkyTrack is going to do, you can see it turn tracking off because, again, a geostationary does not change its position in the sky relative to the viewer. So you can see our alt and as readings here are stationary, not changing. So the mount, the motors are right off. There's no tracking going on. And so let's take an image. So I'm going to take about a 60-second image to illustrate this. And I'll cut the video and we'll come back when the image is about to come back. Okay, so our image is about to come up here. And as you might have suspected, there's actually a grouping of 3 geostationary in the same area here. And you can see all our stars are streaked because we're no longer doing sidereal time tracking, where the mount is just sitting still and our geostationary satellites are sitting still. It's actually a real cluster of them here. So we saw these 3 here. There's another one, there's another one, there's another one. So there's a whole band of them here. So that's geostationary. And if you want more information about any satellite, you can click the satellite information. And we can see that the origin of it was Brazil. The operator and owner is Spain. And it's almost sitting right over Brazil. But you can see they have a large coverage being so far out. Okay, so that's satellite tracking then. So three types of tracking: the continuous tracking, which only some mounts are capable of; the Leapfrog tracking, which you can do with any mount; and then looking at a geostationary satellite, which again you can do with any mount. So now I want to talk about astronomical objects. So all these different tabs here, if we just do a regular go to, and let's just go to M31. So it's going to go to the object, and when it gets there, it's going to start sidereal tracking, which means the stars are going to be still in our image. And so we're at M31. And I'm just going to do a quick 10-second image there. It's a moonlit night, so it's not going to look real great. Yeah, I got all these gradients, but we can see M31 there, and all our stars are well defined, little dots of light. So that's sidereal tracking, and it'll do that for all the objects, and that's what you want when you're looking at a deep sky object or a star. It works relatively well for solar system, but planets and the moon, the sun, of course, are not moving right at sidereal time. They're moving a little different because, of course, they're orbiting. So we can do a regular go-to to Saturn, and it'll be fine. It'll sit there, but gradually it's gonna drift out of our field of view because it isn't really moving relative to us at sidereal time. Same with comets and asteroids. They're fairly slow moving, so we could see them using sidereal time, and you could actually do some imaging at sidereal time. But if you want to track him, you'd have to use a custom tracking rate. So that's what this last tab here is for, the JPL. It's called JPL because the data comes from the JPL Horizons website, which gives us the custom tracking rates for some of these other objects. So we could do this for a planet. So I'm going to go over here. Oh, I've already got it there. So I'm going to select Saturn. I'm going to download the data, which will give us the tracking rates. Come back here, click custom tracking. And so now it's slewing to Saturn. So we'll see this separation go down and down, and it'll get below 1 arc second. So what it's going to do, the mount is still doing sidereal tracking, but I'm also applying a rate on top of that. Now again, not all mounts are able to do this. So if we go back to our ASCOM capabilities, this can set RA rate and can set DEC rate. These have to be yes. So now if we were viewing or imaging Saturn over a long period of time, Saturn wouldn't drift out of our field of view anymore. So what it's doing, if we actually look at the data here, what it's doing, it's applying this and this. These are custom tracking rates that it's applying on top of sidereal time to keep it right in the field of view. So you could do that for planets. There's all sorts of objects that you could look at in the JPL database, and I'm just going to pull up this one. This is the Chandra Space Observatory. It's an X-ray observatory. So I'm going to download the data for it. Again, this is downloading from JPL Horizons from this website here. I'm going to click on it. It's really high in the sky right now. So I'm going to enable, keep that enabled. And we're going to slew to that. So again, as it gets close, we'll see this separation start to drop. And now we're closing in on it. So again, I'm going to let that drop below an arc second. And then we'll attempt to image it. Okay, that looks good. And I'm going to do about a, let's do a 2-minute image of that. That'll demonstrate it nicely. So we're tracking the observatory. We're not using sidereal time, so our stars are going to be streaked because it's a different rate. So we're tracking exactly the movement of that space observatory. And again, I'm going to cut the video and we'll come back when my image is about to come up. Okay, so here comes our image. And it looks like a mess, right? Because we don't have, we're not tracking at sidereal, so all our stars are all blurred because we were tracking at that custom rate. We're just going to zoom in. I'm just going to use the aberration inspector. And we actually lost it. It's right behind this star here. So you can't really see it, but there's a little dot there. What I can do is I'll show you a picture from another night. I don't think I have one. Okay, I can show you this one. Same type of deal. So this was this GSAT 6A. So I was tracking on it. You can see all the stars are blurred, but using those custom rates, we could actually we actually tracked it quite nicely. And it's just a little dot here. And unfortunately, this wasn't a good example because it is. You just see the little dot here, but we got this star streaking through our image. Maybe we'll try that again later. So starting with this version 1.72, you now can actually do custom tracking for comets and asteroids. So if I just do a go to, from this screen here, it'll go to the location of the comet. And I have a filter here, so I'm just looking at objects that are brighter than 12, their magnitude. So it's pointing to the comet now, but it's doing sidereal time tracking. So our stars would stay as nice little round dots, but if we did a longer exposure, the satellite, or the comet is going to blur a little bit. And it depends what you want. You may want to do this, or you may want to do the custom tracking, and I'll explain that in a minute. Let's do the custom tracking. So what we do is we select our comet on this screen, but instead of slewing to it, we're going to hit this button, which is going to again download that JPL data. And so I've been able to link the comets here to the JPL database, because these comets are from a different source. Okay, so there it is there. And I'm going to watch what happens. I'm going to click Enable Custom Tracking Rates. And you can see it was already 24 seconds off that it had drifted. So now that we're using custom tracking rates, and I'm doing closed loop tracking, it's going to bring that down. And now we're tracking this comet under an arc second. So let's take an image of that, and hopefully its stars are going to interfere again. And I'm going to do a 60-second image of that comet. So again, I'll cut the video and we'll come back when the image is about to come up. Image is about to come up, and we should be seeing a comet. And there it is. You can see we had a satellite go through our field of view. And let's zoom in a little bit. So there's our comet. You can see our stars are a little bit oblong because we weren't doing sidereal time tracking. So if I did that for like 3 minutes or more, we'd start seeing all the stars streak. But our comet will be well defined because we are tracking the comet. So the comet is almost in the center of my frame here, but we could track all night and it would stay there because of that custom tracking rate. Now, like I mentioned, you may or may not want to do custom tracking for comets and asteroids. And I'll give you an example. So here's something I did a little while ago. And so what I did here, this is really time lapse over 4 hours, and I took a bunch of frames, several hundred frames of this comet, but I didn't use custom tracking rates. I used sidereal time because for this effect I wanted the stars to stay still and I wanted to see the satellite moving across the star field. Now you could do the same thing with the custom rate tracking, and then what we'd see there is we'd just see the satellite sitting still here and we'd see the stars moving by. So it's, all motion's relative, so it depends what the effect you want, which type of tracking you want to use. But it's fun stuff to play around with. So we could do the same thing with asteroids and such. And I just want to go back. Let's try this once more. Hopefully it's not behind that, or sorry, not behind, in front of that star anymore. And so we're going to slew back to it with custom rates. And there we started our closed loop tracking. What closed loop means is it looks at the exact position of where the object is and looks at the exact position of the mount. It's also applying those custom rates, but it's also making up any delta. So if there's a difference here, it'll adjust the custom rate just slightly to keep it right centered. So it's under an arc second again. And so we're going to go back and I'm going to try a 2-minute image once again. And hopefully it's not in front of that star anymore. So we're imaging, and again we'll cut the video and I'll come back when the image is about to come up. And we're back again. Our image is about to come up, and hopefully this time we'll be able to see it. Well, almost. It's just on the edge of that star streak. Of course, when I want to do a video, it's obscured by a star. Here's one from the other night. So you can see all the stars are streaked, and there's the Chandra X-ray Observatory there, right dead center. So that's an overview of the different types of tracking in SkyTrack. And I hope you find that helpful. And if you need any clarification on anything, please ask your questions in the comments. This new release with this custom tracking rates for comets and asteroids, I expect to have that available for download in another day or two. I just have a little more testing, but it seems to be working well. So thanks again for now.